In this video, we're going to look at an example of an improper integral where both limits of integration are infinite. So we're being asked to determine whether or not the integral from negative infinity to infinity of cosine of pi t dt is convergent or divergent. Since we have two bad limits of integration, if you will, we need to split this into two integrals at some intermediate point, and then handle two separate improper integrals. In order for the original integral to converge, we have to have both of these new improper integrals we just created to converge. If even one of them does not converge, the whole thing diverges. We get to pick any point we want, so we'll pick 0. That's pretty convenient. So we'll rewrite the integral as integral from minus infinity to 0 of cosine of pi t dt plus the integral from 0 to infinity of cosine pi t dt. We will replace each of those bad limits of integration with a variable and let each variable go off to negative infinity, infinity, respectively. Remember that these are two separate limits here. They have nothing to do with each other, so to make sure that we keep track of that, we'll use a different variable for the first one than we do for the second one. So I'll let the first one, b, go to negative infinity, and let the second one, c, go to positive infinity. Both of these have a similar antiderivative. We'll have 1 over pi sine of pi t. In the first integral, we'll evaluate from b to 0. In the second integral, we'll evaluate from 0 to c. When we evaluate the first one, we'll have negative 1 over pi sine of pi b. In the second one, we'll have 1 over pi sine of pi c. Now, in this particular case, we notice that neither of these limits exist because sine is an oscillating function. It keeps going up and down forever. It goes between negative 1 and 1 forever. So neither of these limits exist. But even if one of them did not exist, we had come up with the same conclusion. That is that the original integral diverges.